We're going to continue with logarithms today, and we're going to investigate one little fact that I didn't mention yesterday. We're building up to these. Logarithm is known as a common log. The base is 10. So in other words, if you saw something that said the log of 3, there's no base written here. If there's no base written there, it's always assumed to be base 10. Okay, we're going to get into that further today. But first, let's look at earthquakes. Isn't that cool? Earthquakes are described by base 10. So there's a really cool earthquake map you can go to. And here's a picture of that earthquake map. And as right now you can see that right here there was an earthquake on Sunday. So I'm making this video on 12/13/2015, and in Mexico there was an earthquake. You can look all over the world for earthquakes, and it shows you. So the biggest one we can see, okay, there was one right here in the mid-Atlantic range, is a 4.9 earthquake. We can change this, and I can look for the past 30 days of all the earthquakes worldwide. And then they show up. There was a big one right there. Let's see what that one was. That one was a 5.5 on Ascension Island. And we can always zoom to my location. Let's see, was there any in the Northeast? Nope, nothing in the past 30 days, but every once in a while there is. In fact, if I go up here, I believe, up on the Canadian border, oops, where is it? Right there. There was one, 3.3 in Cornwall, Canada. So it's kind of cool just to go around and see how often there are earthquakes. And half the time people don't feel them because they're very tiny. Look, in the past 30 days, it hasn't looked well, but hey, the mid-United States over here was getting, wow, there's been a lot of grumbling right here. They're small ones. Let's zoom in a little bit. Poor Oklahoma. Man, they get tornadoes, they get earthquakes, they get everything. So the biggest one looks to be right about there. Let's see what that one was. There it is. That's the biggest one right there of a 4.0. But anyway, what does this all mean? Earthquakes are on a scale of logarithmic. So when I said the earthquake was a 4.0 earthquake, that meant the exponent of base 10 is 4. So that's really 10,000. So if somebody had a 5 for an earthquake, that means that earthquake is 10 times stronger than a 4. Now, here's the big thing. Most people think earthquakes only go up to a scale of 10. But they can go above 10. We just haven't had any that big because they're just based on the log scale. Imagine if you had an earthquake of 12, the devastation that would happen? We hope not. All right, so over here, we have what that base 10 really means. 10 to the 0.3177 power is roughly the number 2078605, roughly. Now look what 10 to the 1.3177, 10 to the 2.3177, 10 to the 3.3177. See, all the decimal, they're all the same numbers. All that's moving is the decimal. Every time I go up a power of 10, it means multiply by 10. So the decimal keeps moving to the right. All right, so let's say somebody asked you to take the log of 279. Exactly what are they asking you for? Remember, logarithm is fancy phrase for what is the exponent. And if the log means base 10, if no other base is referred. So this is really asking you this. What is the exponent of, remember there's no base there, 10, so that has to be the base, that gets you the number 279. So I would write it as this. Base of 10, we don't know what the exponent is, but we want our answer to be 279. Well, we know x has to be between 2 and 3. 10 to the second is 100. 10 to the third is 1,000. And that's where your calculator can come in. You simply have to press the log key and then the number 279, and it will do the math. And you can see the answer is 2.445. So let's say 2.45 roughly. Makes sense. X is approximately 2.45. And that's exactly where we said it would be, somewhere between 2 and 3. So remember, since exponents and logarithms are the same thing, we want to go back to our exponent laws. If we're multiplying our bases together, then we're adding our exponents together. If we're dividing our bases, then we're subtracting our exponents. And if we're raising an exponent, that would be my husband creating chaos in the back and all the animals running to him. Thanks, honey, for being quiet while I record. All right, so picking up where we left off after I think the Christmas tree fell over. Whatever. If we're going to write these exponent versions in log versions, this is what happens. Since remember, we are adding exponents together, this is what this is saying in essence. The exponent x is added to the exponent y. And when we're dividing, we are taking our exponents and subtracting them. And then here's the interesting one. When we are multiplying a power to a power, I really shouldn't be saying a power to a power. We're multiplying an exponent to an exponent. That y exponent falls down in front. Well, we'll explain that in one of the examples we're going to do. It'll make much more sense. Okay, we're going to practice just rewriting logarithmic problems, not really solving them quite yet. So for the first example, all right, we have, what is the exponent of base 4 that gets me 16 times x? Well, we want to write this because we're dealing with exponents. We want to apply our exponent laws. There is no such thing as multiplication. When we're multiplying, as we can see here, we are really adding the exponents together. So this would be rewritten as, what is the exponent of 4 that gets me 16? And then I want to add to that the exponent of 4 that gets me x. Right? Since I'm multiplying and these are exponents, I end up adding. Now I could take this a step further and I could say, well, I can do this. I do know the exponent of 4 that gets me 16. That's 2, but I don't know any more. All right, for the next one. What is the exponent of, well, there's no base written here, so that means it's 10. So I'm just going to put 10 down there so you can understand it. X cubed divided by 100. All right, let me rewrite this now. I'm dividing, so that means I must be taking the exponent and subtracting the other exponent. Now, x cubed is really the log of x times x times x. And wait a second. I can't have multiplication because I'm dealing with exponents. Oh, so this is really the log of x plus the log of x plus the log of x minus, well, since there's really a 10 here, what is the exponent of 10? That gets me 100. 2. Now I can even clean this up a little more. And this is where it may get a little confusing. I can rewrite that. I can say that I have three exponents of x. Okay, now I'm going to come back to this one I just talked about. Do you see what happened here? I had an x to the y. And that y fell down in front. Well, I had the same thing right here. I had the 3. I could have gone from this step right to there by having the 3 come down in front, because this is just x multiplied together 3 times, which means I have 3 exponents. I'm going to actually skip to number 4 before I do number 3. Because number 4 is just like 1 and 2. We want to rewrite log 3 square root of 5 divided means I'm subtracting log 327. All right, still have one little issue right here. You really have to realize that square root is fancy for to the half power. So if I were to rewrite this totally, let's use this shortcut from up here over here. I'm going to have this 1/2 fall down in front. And then what is the exponent of 3 that gets me 27? 3. And that's how I could rewrite that. Notice I'm not solving it, I'm just rewriting it. But now I could take out a calculator here and I could solve this. And remember, that would give me the exponent of 3 that gets me that answer. But we're not there yet. We're just trying to get you used to how to rewrite these things. The one that Regents loves to give you are what I call these playful ones. In other words, they want you to play around and see the connections. So they want me to take the log of 12 and express it in terms of a and b. So the log of 12. All right, well, what did they tell me? This is what they're telling me. Every time I see an a, I may replace it with the log of 3. Or every time I see the log of 3, I may replace it with an a. Every time I see a b, I may replace it with the log of 2. Or every time I see the log of 2, I may replace it with a b. So what does that mean? Well, hopefully you see the number 3 and you see the number 2 and you say to yourself, well, the log of 12 can be rewritten as 4 times 3. Ooh, there's that 3 I was looking for. That can get rewritten because I'm multiplying exponents. I'm really adding them. The log of 4 plus the log of 3. Well, that's great. This said, every time I see the log of 3, I may replace it with the letter a. Hey, there is the log of 3. I can replace that with an a, but I don't see the log of 2 anywhere. It's hidden. It's hidden here because I can rewrite the log of 4 as 2 squared. And then I can look at that as having 2 logs of 2 plus a log of 3. And now I've got my connections. There's that log of 3. I can replace it with the letter a. And there's that log of 2. I can replace that with the letter b. So to rewrite this in terms of a and b, it would be 2b plus a. And that's how the Regents is getting around you just using your calculator to find the answer.